Okay, so we are going to solve paper 6 of October-November 2022, paper 6-1. So the part A is investigation. This is based on isosceles trapeziums. So we're not advised to spend more than 50 minutes on this part. So let's read through it. This looks at equilateral triangles in isosceles trapezium drawn on 1 centimeter isometric grids. There is an additional isometric grid on the actual paper that is somewhere around the end of this section. If you wish, you can use this, but I don't think so. I'll feel the need to use that. So there are 16 unit triangles in the equilateral triangle. Okay, let's go to the first question. So first of all, what is a unit triangle? It is a equilateral triangle of side length 1. In this task, all shapes can be divided into unit triangles. So in this case, there are 16 unit triangles in equilateral triangle with side length 4. These are the first 3 equilateral triangles in sequence: unit triangle, side length 1, side length 2, side length 3. So we have to count the number of triangles in each of them. So let's see, this is obviously 1. So next is for 2, how many triangles do I see? I can see 3, 1, 2, 3, 4 triangles. In 3, I can just count how many are these. So if you count, how many do you get? 1, 2, 3, 4, 5, 6, 7, 8, 9. You get 9 triangles. And in the next one, the fifth one, so no, not at all difficult to guess. This is 1, 4, 9, 16. So this one has to be 25. Now write down an expression in terms of x for the number of unit triangles. So obviously you can see the pattern. It is x squared, because if it is this is 1, then square of that is 1 square. This is 2, square of this is 2 square. So if it is x, then it will be x square. So my answer being x square for in terms of x. Now the next question, be the first 3 isosceles trapezium in a sequence. The length of each sloping side is y. So we can see that this is talking in terms of the slanting length of this trapezium. So here it is y equal to 1, y equal to 2, y equal to 3. So if we just count the number of unit triangles here, you can see in the first one, this is 3. Second one, I can see this is, how many are there? Let's check. These are 3, 4, 5, 6, 7, and 8. So I can just count again 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 here. Similarly, in this one, if I count, let's see. Let's just draw the triangles quickly and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And similarly for 4, it has to be 24. What you can also see is, one triangle has been cut off. So if it is a triangle of side 2 centimeter, then it should be 2 square and one triangle is removed. So it's like 2 square minus 1. So that's the exact pattern that we see over here. So even here, if I see this is, you can just observe the pattern. So the next question, find an expression in terms of y for the number of unit triangles. Give your answer in the simplest form. This is very important. Do not forget to write it in simplest form. So now what is y? Y is the number of, is the length of the sloping side. So if the length of the sloping side is 1, my unit triangles, there are 3 unit triangles. If it's 2, I can see some pattern over here. This is like, I can say this is 4 minus 1, this is 9 minus 1, this is 16 minus 1, 25 minus 1. So it's 1 less than a perfect square. If I have to write in terms of squares, I can say this is 2 square minus 1, this is 3 square minus 1, this is 4 square minus 1, this is 5 square minus 1. But this corresponds to y equal to 1, this corresponds to 2, this corresponds to 3, this corresponds to 4. So I can see it's kind of plus 1. So if I have to write in a relation, it can be y plus 1 the whole square minus 1. So this is very logical. If you observe it carefully, you can get it. So y plus 1 the whole square minus 1. So we can just compare it again, just you can pause the video and just try to understand this. So now when I expand this, you can just write it as y square plus 2y plus 1 minus 1. It's just using a plus b the whole square formula. And now this simplifies to y square plus 2y. This is my final answer, which is in the simplest form. Now moving to the next question. This is the third question. We have first three trapeziums in another sequence. The length of each sloping side is 1 and the length of the shorter parallel side is w. So we have a fixed length of side 1, which is the sloping side, and this is 1. So let's see this again. I can just see that over here the triangles that are removed from the big triangle, it's like here 2 by 2 triangle is removed, here a 3 by 3 triangle is removed from the big triangle, and so on. So I can easily see that this is 2 square, so 2 by 2 triangle, from that I am removing 1. Here I can see that it's 3 square minus 2 square, and so on. So this is 4 square minus 3 square, and this is 5 square minus 4 square. Let's see if it actually comes out. Yes, this is 4 minus 1, 3. This is 9 minus 4. That should come out to be 5. Let's verify it. 1, 2, 3, 4, and 5. So yes, it is indeed 5. Similarly over here, 1, 2, 3, 4, 5, 6. And I think 1, 2, 3, 4, 5, 6, 7. Yeah, 7. So this is properly verified. So this is 25 minus 9. 25 minus 9 gives me 16. Yeah. So wait, this is 25 minus 16 is 9 actually. Sorry, this is 9. So now I have to find out an expression in terms of W for the number of unit triangles. Again, give you an answer in the simplest form. You have to give your answer in the simplest form. So I can see the patterns over here. If I just write down, this is 3, 5, 7, 9. This is an arithmetic sequence. I can see the common difference is 2, 2, 2. So the first term is definitely something like 2. It's of the form 2a plus b. This is what? This is of the form 2a plus b, where this a is actually, this is a n plus b. So when I talk of a n plus b, a is my difference. So here it is something like, here it is in terms of w. So it is 2w plus something. Now how do I know that plus something? You can just see that if I put w equal to 1, which is my first term, so it is 2 into 1. So that is 2 into 1 gives me 2. I want 3, so I'll just do plus 1 over here. Just plus 1. You can also take it as a difference of these two terms. You could also use the formula for Tn, that is a plus n minus 1d, and then use your a as the first term. So in this case it is 3 plus here it is w minus 1 and d is 2. So if you simplify this, here also you get the same answer, which is 3 plus 2w minus 2, which simplifies to 2w plus 1. So final answer is the same. You can use whichever approach you feel comfortable. Now moving on to the fourth question. These are the first three trapezium in another sequence. The length of each sloping side is 3. The length of the shorter parallel side is w. So okay, so we can see that this is 4 by 4 triangle, but one triangle is cut off from this if I were to see this carefully. And here also a 2 by 2 triangle is cut off. Here a 3 by 3 triangle is cut off. So I can say this is 4 square minus 1 square, which gives me 15. This is 5 square minus 2 square. So 25 minus 4, that's 21. Then the third one is 6 square minus 3 square. So that gives me 36 minus 9, which is 27. And this is 4 square, sorry, 7 square minus 4 square, which is 49 minus 16. So 49 minus 16 gives you 33. You can definitely use your GDC wherever you feel like. But till this point, there was really no need of a calculator. Well, you're free to use it at any point. So we have question B now. Find an expression in terms of W for the number of unit triangles, and again give me answer in the simplest form. So I can see that here when I compare this first term, this is 1 and 4, 2 and 5. So you can see there's a plus 3 thing. The first term I can write it as something plus 3. It's in terms of W. So W plus 3, because this column is my W. So W plus 3, I square this. And from that, I am removing what is exactly my W, square of W. You can see this. This is 3 square. So this is minus W square. And I open this up. So this gives me, again using A plus B the whole square formula. So W square plus 6W plus 9 minus W square. That leaves me with just 6W plus 9. Now to find out the value of W when there are 93 unit triangles. So 93, I just have to equate this to 93. 6W plus 9, that gives me 93. And solving this gives me what is 6W is equal to 84. 93 minus 9, and W is equal to 14. That's my final answer for this. Now the next part of this question. In each trapezium, the length of the shorter parallel side is W. Length of each sloping side is Y. Show that an expression for the number of unit triangles is Y into Y plus 2W. You just need to read this question carefully, and you can also refer to the previous one. We could see that in the previous question, when I am cutting off a triangle of, like when this length is W equal to 2, it's a 2 by 2 triangle that is cut off from here to make an equilateral triangle, which is like this is 3 plus 2. So in the same way here, we have Y, and if I were to complete this triangle, this will be something like W, right? So it is like this is my equilateral triangle, this is Y plus W. So we already know that what is the total number of triangles in the whole bigger triangle. So the bigger triangle is length Y plus W. So Y plus W will have how many triangles? Y plus W square, because that is that's the result which we got in the very first part of the question. That is how many squares. So if I have a unit triangle of length 2, then 2 square. That is the number of the length of the entire triangle if it's 2. Then the number of unit triangles are 2 square. So here the length of the side is Y plus W. So in the entire triangle I have Y plus W square. But I do not want this small triangle in that. So I will subtract W square from this, which on simplifying, so again A plus B the whole square, so Y square plus 2YW plus W square minus W square. This gets cancelled off. So what I'm left with is Y square plus 2YW, which factorizing, on factorizing gives me Y plus 2W. That's my required answer. Now moving to the next part. In a trapezium, the length of the shorter parallel side is equal to the length of the sloping side. Is it possible for the number of unit triangles to be 300? So the number of anything, this has to be an integer. So we just have to equate that to 300 and see if it is possible to get 300. So this formula, which is Y into Y plus 2W, Y into Y plus 2W is equal to 300. The other condition is that length of the shorter parallel side is equal to length of the sloping side. So we can just equate the Y and W together. So in this case, let's say if I just take my y to be equal to w. I know that y is equal to w, so I will just equate that. So that will give me let me just replace w with y. So y into y plus 2y is equal to 300. That gives me y into 3y, that gives me 3y square is equal to 300. And that gives me y square is equal to 100, which further gives me y equal to 10. And as y is an integer, yes, it's definitely possible. So as y is an integer, it is possible. Next, find the length of the sides of all the trapezium with exactly 160 unit triangles. So again, the same formula. I have to equate it to 160 and get the possible integer values. So y into y plus 2w, that is equal to 160. Now this is, I need to find out the factors of 160 here. So this is 160. Okay, what are the possible factors? 1 into 160, 2 into 80, 4 into 40, 5 into 32. It won't go in 6. 8 into 20, and then you have 10 into 16. And after this, I think if I just take 11, it won't go in 11. 12, it won't go. 13, 14, 15, it won't go. 16, I think then the factors will repeat. So I can just take these possibilities. Now I will just take every possible value of y. So let me just try y equal to 1. So if y is equal to 1, the other factor, this has to be 160. So y plus 2w is equal to 160. Now with this combination, this y is equal to 1, so 2w will become 160 minus 1. So that will give me 2w is equal to 159. So this is going to result in a w which is a fraction because it's an even number, 2w. But if I divide by 2, it will give me something as a decimal. So it's w cannot be, 2w cannot be this way. So this is not possible. Let's take y equal to 2, which gives me y plus 2w is equal to, this should give me 80, which implies 2w is equal to 80 minus 2, which is 78, which gives me w is equal to 39, which is an integer. So this combination is possible. Let's try y equal to 3. That gives me y plus 2w is equal to 40, which implies y is, no, sorry, this is y equal to 4. I cannot take 3. This is the next combination. So y is equal to 4. So that gives me, so this is 4. So 40 minus 4 is 36. So 2w is equal to 36. And that gives me w is equal to 18. So this combination is also possible. Let me try y equal to 5. Now I think again we can see that these odd numbers are not going to result in any answers. So I can still see that y plus 2w is equal to 32. That gives me 2w is equal to 32 minus 5, which is an odd number. So this is again not possible. Y is equal to 8. I think this will definitely give me. So y plus 2w is equal to 20, which implies 2w is equal to 20 minus 8 because y is equal to 8. So which is 12, which implies w is equal to 6. Again an integer value, it's definitely possible. And the last one, y is equal to 10. That gives me y plus 2w is equal to 16. And that gives me 2w is equal to 16 minus 10, which is 6, which results in w equal to 3. So the possible values which I have underlined, we have 4 pairs of values. So 239, 418, 8, 6 and 10, 3. So these are the length of the sides of all trapeziums with exactly 160 unit triangles. So this was the investigation part A. Now let's go to the modeling. There is a part B, which is also for 30 marks. You will definitely need a GTC here. So I'll just keep the GTC ready right away over here. So, okay, let's read this question now. The task is about the cost in a pizza business. Pablo is starting a pizza business. He collects information from pizza businesses to set up mathematical models. He assumes that he sells pizzas he makes, all the pizzas he makes. So the first model is he sells one type of pizza with selling price of $10. He sells n pizzas per week. It costs him $2 to make one pizza. His running costs are $400 per week. He employs 2 people each costing $300 per week. And this is how he works out his profit. That is income from selling pizzas minus his costs. So show that a model for the weekly profit, that is P dollars in terms of N, is given by. So if it is to show that, make sure you show enough steps here. So income minus cost. So what is my income here? So he's selling at the price of $10 and he sells n pizzas per week. So this will be how many, what is his earning? His income will be 10n. So that's my profit. Mine, that is my income and all the costs that he has. So what are the costs? It cost him $2 to make one pizza. So he's making n pizzas. So that is 2n. Then his running costs are 400 per week. This is weekly profit. So again minus 400. I will add them to the cost. This is plus 400. And he employs 2 people costing 300 each. So 300 into 2. So this will be plus, there are 2 people into 300 each. So when I add this all, so this is 10n minus 2n minus 400 minus this. So that is minus 1000. So that simplifies to 8n minus 1000. Next, Pablo wants a profit of at least 500 per week. Use the model to find the minimum number of pizzas he must sell per week. So what I need here is this should be at least 500. So 8n minus 1000 should be at least 500. So it should be greater than or equal to 500, which if I simplify gives me 8n is greater than or equal to 1000 goes that side. This gives me 1500 and n is greater than or equal to, what is 1500 divided by 8. So let's see, this is 1500 divided by 8. That gives us 187.5. But this is at least, so I cannot have 187.5. So my final answer has to be the next integer after that, which is 188. Pablo expects sales to vary. He says the following conditions. He opens 4 days per week, 6 hours per day, makes 16 pizzas per hour for half of the time, and makes 8 pizzas per half for the rest of the time. Can Pablo make a weekly profit of $500? Use the condition above and your answer to part B to show that how you decide. Okay, so here let's read this a little more carefully. So we have the total time that we have This was answer to part B. Answer to part B was that he can make use the model to find the minimum number of pizzas he must sell. So he is selling a minimum of 188 for sure. Okay, so yeah, so we will just have to find out this result if he can make a weekly profit of 500. So if he's able to sell more than 188, then he can make. So that's what we have to find out. So let's see how much time he is spending. So total time is for which he works is 4 days a week, 6 hours per day. So 4 into 6, that is 24 hours. And he makes 16 pizzas per hour. So how many pizzas he is making? Half of the time, and 8 pizzas per hour for the rest of the time. So I can just divide this 24 hours into 12 hours. So this is 16 into 12, and you have 8 into 12. So you have 16 into 12. That gives me 192. And then I have 8 into 12, that's 96. Now add this, I get total of 288. So as he's making 288 pizzas, this is the total number of pizzas which he's making. Total pizzas. And as this is greater than 188, you can definitely make a profit of. So hence, he can make a profit of more than $500. Okay, next is he makes changes to the conditions. These are the new conditions now. He sells one type of pizza with a selling price of X dollars. He sells N pizzas per week, costing $2 to make one pizza. His running costs of $400 increased by 50%. He employs 3 people, each costing $300 per week. Use these conditions to show that the model for the weekly profit is this. Okay, so again we have to first calculate the costs and what his profit is per pizza. So he sells at this and it costs him $2. So my profit per pizza is is X minus $2. It's not exactly the profit, but it is his, let's say, I won't call it as profit really. So what he earns per pizza. So that is X minus 2. Now his actual profit will be this earnings. So per pizza, this is what he gets, and he sells N pizzas. So this is the effective cost per pizza, you can say. Okay, his earning per pizza, you can say. Earning per pizza, and he sells N pizzas. So his total profit would be his earning from all the N pizzas, which is X minus 2 into N. From this, I have to subtract his costs. So his running costs are $400, but it is increased by 50%. So this is $400 into 50% increase would be 1.5, plus he is employing 3 people, each costing $300. So this is 300 into 3. So the total cost comes out to be X minus 2 into N. This must come out to be 1500. So let's just check this here. So this is 400 into 1.5 plus 300 into 3. Let's check this. Yes, it is 1500. So we are correct. So that's shown. So the pizza business is now open for 6 hours per day and 6 days per week. It continues to make 16 pizzas per hour for half of the time and 8 pizzas per hour for the rest of the time. Work out the number of pizzas the business can make per week. So now it is, earlier it was given in terms of sells, okay, selling price, and it is said that it makes n pizzas per week. So I can just talk in terms of 6 hours per day and 6 days per week. So Annie is making 16 pizzas per hour. Okay, so what we have the actual number. So how many hours it works? 6 into 6, 6 hours, 6 days, so that is 36 hours, and half the number of hours, so 16 into, out of this 18 hours, 16 pizzas plus 8 pizzas for remaining 18 hours. So that gives me 16 into 18 plus 8 into 18, that gives me 432. This is 432. So per week he will make 432 pizzas. Moving on to the next question, the C part. He wants a weekly profit of at least $500. Use the model in part A and your answer to part B to work out the minimum selling price of a pizza. So what was my model in part A? Part A, I have got x minus 2. So this is my profit, and this profit, he wants a weekly profit of 500. So I'm going to equate this to 500. At the same time, I'm also going to uh, take my number of pizzas, that is my n, as 432. So I have to find out the minimum selling price, which is my x over here. So it will come out to be x minus 2 into n, which was 432. So 432 into 432 minus 1500, which is my model here, 1500. This should be equal to 500. So if I solve this further, I will get my x is equal to, you can just see this is 2000, 500 plus 1500, that is 2000, and 2000 upon 432 plus 2. That gives me, you can just see this is the calculation. You can use your calculator or any other method that you find convenient. So 2000 divided by, is divided by 432 plus 2, and that gives me 6.63. If I round off to 2 decimal places, that is 6.63. Now this is model 2, where Pablo makes a model for the relationship between the price of pizza and number of pizzas he sells. He uses the following information. He sells 480 pizzas per week when the selling price is 5 per pizza, $5 per pizza. He sells 60 pizzas per week when the selling price is $20 per pizza. Pablo assumes this relationship between the selling price of a pizza, and that is x dollars, and the number of pizzas he sells per week, n. This is the relation. Write down and solve a pair of simultaneous equations so that a is equal to minus 28 and b is my 620. So you have to first use the information to frame the equation. So here you have 480 per week, that is number of pizzas, so that is 480 is equal to Now what is A over here? Number of pizzas he serves is N and price is X. So that is $5. So that is 5X plus B. This is my first equation. The second equation will be 60. When it is 60 pizza, that is 20 per pizza plus B. In solving this equation, if I just subtract these two, now because it is for 4 marks, you have to show the working. So you cannot just input the values in the GDC and write down your answer, though you can definitely verify. So let me just subtract the two equations. When I subtract the two equations, I get 420 is equal to, this is 15x. Okay, this is minus 15, right? This is 5 minus 12, this is minus 15. So x equal to 420 upon minus 15. So 420 divided by minus 15. That gives me minus 28. And when I put my value of x in one of the two equations, so let's say 60 is equal to 20 into minus 28 plus b, that gives me my value of b, which will be 60 plus 20 into 28. That gives me 620. 620. So these are my values of x and b. We can see that it is indeed equal to that. So you have to show that. You cannot just state the answer directly from the GDC. Now model 3. Pavlov wants a model for the weekly profit P in terms of the selling price X of the pizzas. Use question 7a and 8 to show that a model for the weekly profit in terms of X is minus 28x square plus 676. Okay, so let's see this. Question 7a was, okay, that is x minus 2 into n minus 1500, and you have question 8, that is these values. So we just need to equate them. So he wants a model for the weekly profit. Now this is, what does this give me? This is the number of pizzas he sells. Okay. So the number of pizzas he sells, so that's my value of n over here. So in place of n, I have to substitute that 628. So that equation which I got, I'll just replace a and b in that equation, and so that becomes my cost which of selling the pizzas minus this 1500 is, okay, so x minus 2n minus 1500. Okay, so x minus 2n, so it's x minus 2n, so n will be obtained from the previous equation minus 1500, that was my profit. So this is x minus 2 and n will be this, that is, now what is my a is minus 28x plus 620 minus 1500 is my answer. Now you just have to show one step of simplification, after which you can directly write. So if I just multiply this minus 28x square, you can only see that is my first term, minus plus actually 56x, then you can just multiply this again, which is plus 620x minus 620 into minus 2. Okay, so this is minus the 620 into, so 620 into minus 2. That gives me minus 1240. And if we simplify this, we must get this. So we can directly write this. So minus 1500, of course. So the final answer that you get is minus 28x square plus 676x. You can see that when you add these two, you get this, and when you add this, you get minus 2740. The next part is sketch the graph of the model on the axis. So you have to get a proper sketch here. So my model over here is minus 28 x square. So, okay, so I have to use this. I have to input this in my GDC, but also make sure you just select all the settings properly. So this is now, let's go to the graphing. So that gives me minus 28. So minus 28 x is the correct x from here. Okay, sorry, this is x square plus 676 x minus 2740. This is my graph. Now the settings have to be such that this is, so x is from 0 to 25. So shift new window. The x minimum is 0 and maximum is 25. And they haven't given these settings, so you'll have to just figure that out also. So let's draw this. So this is my first, okay, sorry, this is just exit from here. Okay, exit, and now draw this. Okay, I think something wrong here. Let's check this. Just zoom out a bit. Okay, seeing something new. Let's see what is wrong. Minus 28 x squared plus 676x minus 2740. Let me just check if this value is input correctly. Yes. And I have to see my viewing window. X minimum, as it shows here, is from 0 and 25. And I think the x values, you need to just check that also. I think it will be approximately, let's take a bigger value and then we'll check it out. So let's just have a look at, we'll just take some huge values. Let's take 100 to 100, minus 100. Let me just try minus 100 and 100. Just give us an idea, so we can just draw it out now. Let's draw it. Okay, so yeah, so this is the problem here. So we just need to scale it down also. We'll just see what is our maximum. So we can just have it that way, that is shift gsolve, what's my maximum. Okay, so my maximum is somewhere close to 1340. So I'll just scale that also. So I'll just take something like, let's say this was 1340 something. I'll just take this, let's say this is 1341. I'll keep that as my maximum. Let's check the minimum also, if there's any minimum, or at least the y-intercept. So shift, we check the y-intercept, because there's a parabola, so you won't have a minimum, but what's the y-intercept? That's 2740. So let me just roughly keep this negative 27. Okay, so I think this will help now. If I just, okay, let's keep the minimum values here. So y minimum is minus 2740, and the maximum can be 1341. 1341. Okay, let's try it now. Okay, this is perfect now. So we can just draw this sketch from here. So we'll just roughly draw this something like okay, I think this works. Now find the maximum weekly profit and the selling price that gives this. I think we have already worked this out. So the maximum was 1340.14. Okay, so this is 1340.14, and the selling price that gives this will be the corresponding x value, that is 12.07. That is 12.07. Write an inequality for the values of x that give a weekly profit of at least $500. So at least $500. So I just need to solve this inequality. So I just need to solve this inequality wherein simultaneously I need to solve this. So I just have to draw, maybe I can just draw 500 away and just find out the intercept. So let's say if this is 500, so something like this, maybe a little lower. Maybe. So this is 500. I want it to be above 500. So the values that will give me above 500 will be when x will be between these values. Again, I can use my GTC here. So let's just put another value which is 500, and let's draw again. So let's see the intersecting point. Intersect. This gives me the x coordinate as 6.59. So this is 6.59, and the next one over here, this is 17.55. Let's take the approximate 17.55. 17.55. So the x value has to be between these values. So I can write, so the inequality will be 6.59, and it's between these values. So that is 17.5. In dollars, of course, this will be in dollars. Or you can just ignore it because x is already mentioned in dollars. So that was about the modeling paper. So we have solved this entire paper of October-November 2261.